auto probing. Execute. Oh my god. Check it out. Yes, this is a 5-axis CNC machine that doesn't just machine complex parts, it actually understands what you're asking it to do. This is the IFMAKER M5, a true desktop 5-axis CNC machine that aims to make industrial-grade machining much more accessible. Now, for many CNC users, software is always the most difficult part because it comes with a steep learning curve. After using this M5 for a while, I would say this is probably has by far the best software I've used. The machine is set up as an integrated CNC and a CAM system, meaning all 3D programming can be done directly on the touchscreen without third-party software. And the CAM is no joke. Just check out this super complex spherical through-wheel wire body and machine with it, complex spherical surfaces, and multi-angled hole structures. You can ask any professional CNC user how difficult a part like this is. I'll also show later in the software section how I successfully machined with the M5. Under the hood, this machine comes with some impressive specs, including a 2.2 kilowatts, 60,000 RPM high torque spindle paired with closed-loop water cooling. Weighing 135 kilograms with a solid iron base, it maintains micron-level precision, plus or minus 0.01 millimeters for 3-axis work, and plus or minus 0.06 millimeter in 5-axis RTCP mode, with the 4-slot automatic tool changer for seamless tool swapping. It also features AI voice control and a handheld controller, plus support for multiple materials, even very hard materials like a titanium alloy, which is significantly harder to machine than stainless steel. I was able to get my hands on a prototype of the IFMAKER M5 and also visited the factory to learn the story behind it. In this video, I'll show you whether you should actually consider it or not. Let's get started. Alright, first up, we have this safety door. Notice the transparent panel here, which lets you clearly view the running status of the workpiece inside. Coolant tends to splash around heavily during processing, so this door must remain closed during formal operation. I kept it open just for this video to give you a better demonstration. And now let's slide open the door. And you see this core component, the AC axis cradle. What I really want to highlight is that this inline tool magazine is fully integrated directly onto the AC axis cradle. So unlike other machines fitted with separate standalone tool magazines, this one is uniquely integrated into this whole assembly. So one advantage I can think of immediately is during automatic tool change, since the magazine doesn't need to extend and retract constantly, it results in few mechanical failures. And here is the main spindle. Above it is the coolant nozzle. Coolant is delivered directly through this nozzle. Right beneath it is the chip trough, and we can pull out this drawer. This is actually an integrated circulating cooling tank. So unlike other machines that require an external standalone cooling tank, this unit is built directly underneath the machine. This design keeps the overall layout neat and greatly improves the structural integrity of the whole machine. Right, now let's move on to the right side. Here we have the emergency stop button. I really appreciate this design. It's oversized and highly prominent. Just in case of an emergency, just press it to stop it. I say this is very user-friendly safety design. This next button is the tool clamp and unclamp control. Press it to release the cutter mounted on the spindle, so you can manually remove the existing tool and fit any replacement you need. Yeah, perfect. Very steady. Oh, by the way, these tools aren't proprietary. You are not stuck only using IFMAKER's official cutters. You can either pick up standard universal tooling on the open market. That definitely saves you a ton of extra costs, which is a huge plus in my book. Next to it is the USB 3 port, and the dial controls the feed rate override. There isn't much extra to explain there. And now we come to one of the most critical components, the touch screen. It hosts the machine's control software. If required, you can finish full CAM programming and design directly on this screen, including cutting and roughing processes. But I will want to dive deep into this right now because I have prepared a dedicated segment about it, so stay tuned. Oh, I almost forgot to talk about this handwheel. Functionally speaking, all the controls on it can actually be integrated into this touch screen, but they still decide to keep the physical handwheel. So why do they retain it? For one thing, it can be inconvenient to stare at the screen while monitoring the movement of axes or cutting tools. With this detachable handwheel, you can hold it and stand right in front of working area to make precise adjustments easily. I consider this handwheel an indispensable core part of this 5-axis machine. More importantly, this handwheel is equipped with an AI voice interaction function. How to process my first model? If you're a novice operator after a setup, you can simply ask it about the next operating steps. An AI chat window will pop up, displaying a detailed illustrated step-by-step guide to walk you through every operation. That is a real detailed illustration, right? With pictures so everybody can understand. So that's the overall design. It has a really clean industrial look. The rounded body and a simple black control panel give it a modern, understated textile. The full transparent cover keeps things safe while still letting you clearly see the entire machining process. It measures 815 by 570 by 800 millimeters and weighs 135 kilograms. It's surprisingly compact, smaller than a regular office desk. You don't need a dedicated factory space for it. It works perfectly fine in a regular room, studio, or home workspace. But enough about the looks. Let's check out how it actually performs. Before we jump into tangible CNC cutting results, let's break down the software. IFMAKER's self-developed IFCAM platform provided completely free alongside the machine. Software has long been the biggest pain point for CNC machining. Both 3D modeling and full 3D programming come with an infamously steep learning curve. In past videos on this channel, I briefly walked through 4 workflows from model creation to toolpath generation on various CNC machines, yet many professional viewers still question the software's real-world capability, claiming my previous test models were overly simplistic. To address these doubts, I'm pushing the M5 with a genuinely challenging test piece. This spherical 3-way valve body. It looks straightforward at first glance, but this spherical T-component incorporates curved surfaces, intersecting block and branch pipes, and multi-angle inclined holes. 4 5-axis linkage machining is required for the entire production process, which thoroughly tests the machine's precision, rigidity, and synchronous motion performance. Like I mentioned, you can show this part to any seasoned CNC machinist, and they immediately recognize its difficulty level. Honestly, it consolidates every major machining challenge: complex curved surfaces, thin wall structures, multi-angled holes, and continuous 5-axis linkage requirements. If the M5 can machine this part flawlessly, standard simple industrial parts will pose zero issues at all. Make no mistake, IFCAM supports casual, low difficulty projects if that's what you need. The CAM software offers modules like Artist, Professional, and IFCAM 2D. The Artist module is built for artistic carving, ideal for portraits, cartoon figures, and decorative artwork. It supports STL, STP, and image file imports to auto-generate 3D models. The Professional module targets industrial component machining and is fully compatible with the standard STP models. This is the module we'll focus on for today's demo. On top of that, IFCAM packs powerful AI tools, including text model and picture model generation. For example, importing a simple selfie photo will automatically generate a matching 3D model and calculate its complete toolpath with minimal extra input from you. As I mentioned earlier, we are skipping basic beginner test pieces here. Since IFMAKER's software is the most robust we've tested to date, we are running this high-stress machine trial on the spherical 3-way valve body. Fair warning, this software breakdown will keep technical jargon light and skip overly tedious parameter deep dives. If you only want to view the final finished machining results, jump straight to the designated timestamp later in this video. We also ran additional cutting tests on titanium alloy, a material far harder than stainless steel, plus an ultra-detailed main cat sculpture to showcase the machine's fine detail carving capability. First, import your step model file, then head to the Prepare tab to create stock blank size to match your raw material. You can freely adjust the workpiece positioning, then add simple support structures to stabilize thin sections and prevent vibration or deformation during cutting. Next up is roughing under the roughing tab. We use the default D6 flat end mill with the laid offset roughing to quickly strip away excess material and form the parts rough outer outline. I'll walk you through the full roughing calculation for one machining side, then repeat this identical roughing workflow for the remaining 2 sides to finish all bulk material removal. Once all 3 roughing sets are calculated, you can preview the completed roughing toolpaths in a single view. Finishing work for the survival part is split into 4 key stages, starting with parallel finishing. We switch over to an R1 bar nose cutter for 3-axis parallel finishing, which delivers consistent, uniform polishing across all flat and gentle curved surfaces via dense, evenly spaced cutting passes. Then we move to solid wall finishing, built to tackle steep vertical walls and deep curved contours that parallel finishing can reach cleanly. We'll stick with the D6 flat animator here, using 3+2 positional machining aligned to the normal direction of each solid wall. I demonstrate the full setup for one wall, then repeat the same process for the other 2 steep profiles. Once all 3 are set up, we can pull up every solid wall finishing toolpath at once to see full coverage of the part's vertical geometry. After finishing the solid walls, we open the 3D feature machining tab to run mere hole operations on the valve's angled branch ports. This feature toolkit also handles drilling, tapping, slot milling, chamfering, and thread milling for all standard mechanical part features. Select any hole geometry on the model, and the software automatically detects accurate cutting start and end heights. I'll show the setup process for one angled hole, then pull up the 4 set of finished hole milling toolpaths for all 3 ports on the valve. For the intricate spherical curved main body of the T-valve, we move on to dedicated 5-axis finishing. We keep using the R1 ball nose cutter here, and the standard trick of this workflow is generating a conformal draft surface wrapped tightly around the workpiece. This lets the software calculate custom tool angles that perfectly hide the complex spherical geometry, eliminate the uneven leftover stock, and rough surface marks common on cheaper desktop CNC machines. Once all roughing and finished toolpath finish calculating, we navigate to the G-code tab to export a machining program. You can combine all toolpaths for different cutters into one unified G-code file. The IFMAKER M5's automatic tool changer swaps cutters mid-operation with no manual work, streamlining the full machining cycle. You can also run toolpath simulation to spot potential collisions and interference before cutting. So overall, even with this ultra-complex spherical 3-way valve as a tough test piece, IFCAM's tablet workflow keeps every machine step neatly arranged. It eliminates clunky third-party camera integrations and confused multi-window navigation entirely. But how does the actual machine result turn out? Alright. Oh my god. Check out this high precision valve component. Look at this complex spherical curved surface and 3 special distributed pipe nozzles. This part can only be fully machined by the 5-axis CNC machine. Ordinary 3-axis or 4-axis equipment cannot reach all the machining angles of this irregular curved surface. Thanks to continuous 5-axis linkage cutting, the whole surface is extremely smooth and seamless, with a perfect surface finish and precision dimension tolerance. It's really a textbook example of 5-axis high precision machining. And you know, this is probably the most complicated part I've ever done on 5-axis CNC machine, and the M5 successfully pulled off. So I'm really surprised by the capability of it. What do you think about it? Let me know in the comments. Now, look at this S-shaped part. This is made from titanium alloy. Titanium alloy is significantly harder than stainless steel, and it also has poor thermal conductivity and a tendency to stick to tools and spring back during cutting. This already makes it very difficult material to machine. On top of that, the part itself is a continuous variable curvature S-shaped deep cavity. The entire process requires constant 5-axis tool orientation adjustment to avoid collisions and maintain stable material removal. On most machines, this or easy cause vibration, tool marks, or poor surface finish. But the M5 was able to complete it in one go. The final surface looks very smooth, and the curvature is consistent throughout. I also tested another workpiece, that's Maine Coon cat. The surface is covered with flowing spiral textures and highly detailed features, giving it a very complex and refined appearance with a strong visual depth. At first glance, it looks extremely difficult to machine. However, this type of model is actually easier in terms of toolpath logic because it is mostly continuous surface machining without deep undercuts or enclosed cavities. Compared to complex structural parts I talked before, 5-axis machining of this type of geometry is relatively straightforward. And that's all about the machine itself. I also go to IFMAKER's factory and meet the development team behind this product. All the main components are made in-house before final assembly. Work around the office and the workshop and using multiple prototype machines run non-stop. The engineers keep running around the clock tests to polish both the machine hardware and IFCAM software. What stood out to me is that IFMAKER isn't just a hardware-focused company. Like I mentioned earlier, the real strength is probably the software. Instead of relying on third-party systems, they've built their entire control system and CAM software from the ground up specifically for simultaneous 5-axis machining. Because the hardware and the software are designed together, the workflow feels very unified, from toolpath generation all the way to machine control. Everything is built around reducing friction in the process. From a practical standpoint, the M5 feels like a compact but serious 5-axis system rather than a simplified desktop CNC. The structure is rigid, and the spindle setup is clearly designed for real cutting loads. The integrated touchscreen CAM workflow, to a changing system, and the cooling setup all point toward continuous machining rather than hobby use. It's still not a push-button machine. 5-axis work will always require understanding, but the system does a good job of lowering the barrier between an idea and actual machining. So if you've been interested in 5-axis CNC but feel the workflow was too complex, then 5 is definitely a machine worth checking out. If you'd like to learn more, you'll find the links in the description. Thanks for watching. I'm Samuel. See you in the next one. Bye bye.